ice-ocean-lithosphere injections on the Astrolabe glacier, East Antarctica.
Yeah, thank you. So in the next 10 minutes, I would like to present you some preliminary results of an ongoing seismic experiment that we are performing on the Astrolabe glacier. And the principal aim of it is really to look at the interaction of the ice between ice, ocean, and the bedrock. The basic simple question is that the glacier and that the ice sheet flows naturally to the ocean, but that the glacier and ice shelves may become vulnerable in coastal areas facing the ocean warming. So our motivation is really to develop some monitoring of the ice activity on outlet glacier when it reaches the ocean in order to look at the processes that play at the ocean ice bedrock interface, that is to say, in the grounding areas of these outlet glaciers. They are particularly vulnerable in areas where the bedrock is largely below the sea level. Our motivation is really to develop some passive geophysical observation from the Earth's surface in order to monitor the activity at the grounding zone of a glacier. This is the cartoon of the Astrolabe glacier close to the Dumont d'Urville station. It's a project supported by the French Polar Institute. So by deploying GNSS and seismic stations, so we want to look at to make some terrestrial seismology and also to look at what happens at the calving front in terms of processes of ice loss, and also to look at the glacier bedrock structure and also the subglacial hydrology from particularly using the seismic noise. The Astrolabe glacier is slightly west of the Wilkie subbasin, and it's characterized by the relatively small floating tongues, which is 4 by 10 kilometer long. So it's a quite small outlet glacier at the scale of Antarctica, but it's a quite big glacier compared to the alpine glacier. The two images are at the same scale. So it has a quite small floating tongue. It's the thickness at the grounding line here, so it's about 700 meters at the grounding line, and the basin is far reach about 200 kilometers inland. The ice is flowing at about 1 meter per day in this area, so it's derived from mainly from satellite images like this work performed by Provost et al. Published this year, and also by a permanent GPS network deployed for more than 10 years by Emmanuel Lemeur, and that allows to have a long-term idea of the ice flow in this area. So a short summary of the deployment that has been performed this last year. So in January 2022, so we deployed first some semi-permanent station around the glacier on the ice and on small rocky islands. So we now have 6 of them, some broadband seismic station, and we also deployed some small network of 6 broadband instruments on the grounding line of the Astrolabe glacier with an interstation of about 500 meters for several weeks. In last January in 2023, so we deployed a seismic node network on the grounding line of the glacier of 50 instruments, and in that case it's to better record the seismic ice quakes at higher frequencies, and to try to locate the surface and basal seismic events, and also to work on the subglacial hydrology. Next January, so what we are planning to do is to make a kind of proof of concept experiment and to try to use the fiber optics in order to improve one more time the seismic resolution in detecting and locating seismic events. So we plan to deploy some fiber optics interrogated by a distributed acoustic sensor in order to get some much higher resolution. So it's our plan for next season. We also deployed some OBSs in order to get some information on the Earth structure, but also on the calving processes close to the terminus of the Astrolabe. This is the Dumont d'Urville base, so we make some deployment close to the terminus of the station of different kind of instruments. And so the idea is that so we have made short-term deployments of a few weeks, and also some longer-term deployments of OBSs in order to record the calving events, the sea ice activity, particularly during winter time, the iceberg, and also, why not, the bioacoustic sources in this area. So the few preliminary results of our study is that on the grounding line, using the broadband seismic stations, that the recordings are dominated by all these glitches that represent surface ice quakes, dominated by surface waves with a duration of 1 second and a frequency between 1 and 20 hertz. They are very impulsive, so possible to detect and to make some systematic detection of this event. And what we can see on this diagram is the number of ice quakes detected per hour in blue over the few weeks of recordings, and together with the tide gauge, the tide amplitude measured at the tide gauge in the Dumont d'Urville base, and so you see a clear correlation of the ice quake activity with the ocean level, meaning that this activity is strongly correlated to is a result of the strain of the ice slab induced by the water level at the place where it accommodates the torsion of the ice. So in the ice quakes detection, so we retrieve all the lunar phases. So it's clearly showing the strong influence of the tide on the surface seismicity. We also, what is interesting, we also detected numbers of repetitive events that we attributed to basal stick slip. All these events are characterized by a P and S wave, so it's with a very homogeneous delay time between the two phases, and with very homogeneous waveform patterns that suggest that, and their preliminary locations shows that they all arrive from very similar positions, suggesting that they occur on a very particular spot at the base of the ice. So when we detect these events by pattern matching detection, so it's clear that so we have some numbers of these events occurring during the rising tide and at high tide. So there is almost no more events, suggesting that these events are induced by a sticky spot that induce this basal event during the starting time and the late time of the tide processes. So we also use the ambient seismic noise in order to image the ice bedrock interface using ambient noise cross-correlation and surface wave inversion, but also ambient noise spectral ratio analysis. So we observe some kind of thinning of the ice towards the sea, with apparently some high bathymetric ice that could be the source also of the basal events induced by these stick slips. So this is one important information is that the grounding line is not just a line, but it's a complex three-dimensional zone with a complex geometry. So to summarize these preliminary results and of this ongoing experiment, so we observe clearly this ice quake activity modulated by tides, accommodating the torsion of the slab at the grounding line. The basal sliding accommodated also on bathymetric eye, so the grounding area is a complex topographic area which has a complex three-dimensional geometry. So we have a sticky spot that has to be specified in this particular area. So the perspective on which we are working on is to better locate the events, to look also at the subglacial hydrology by seismic noise, and in order to better define the incoming warm water beneath the glacier and the outcoming fresh water, and also to better characterize the calving dynamics at the terminus, and in order to look also at the sea ice activity and the influence of the glacier flow and on the calving. Thank you very much.
Thank you. We have time for a quick question. If there are no questions, we move on. Thank you.